Well, I'll do the intro. Okay, next up, we're gonna have Jean-Frédéric was gonna be talking to us about Kubernetes on effectively Raspberry Pis.
Okay, so it's intended to be a kind of educating, fun, and try to motivate you to try the same experience. There's a demo. I have a bunch of Raspberry which are going to make some light at some point. It's to tell me that I have to start the demo because basically this is going to build a network. And I'm going to, this is basically to, it is the O2 of a Tomcat demo I've been doing at some ApacheCon, explaining how we can do session sharing using the Kubernetes cloud in Tomcat. So I'm Jean-Frédéric Claire, I'm working for Red Hat. You can find me on this email nearly everywhere, on Twitter, on SlideShare. The slides are already available on SlideShare, so if you don't see the small things and you see it better on your laptop, you can just go there. So here I have my Kubernetes cloud made of Raspberries. Basically, I have one box here, which is going to provide Wi-Fi to the others. And I have a master running here, and two nodes which at some point should make some light. Actually, both of them are making some light. So these have created a network on which I have to connect to start the demo, which of course is going to take a while to start. So I have to, that's the first thing when you show how to do a demo, usually the first thing you screw is like, what, you don't have network or something like that. So this demo is basically to show you that you can easily have a Kubernetes running so that you can use it with some space, with very little space. You can have an offline demo of your application that you have prepared for Kubernetes. So at some point I should get network, hopefully. It's trying to connect to the FOSDEM and failed miserably. Okay, I need a few seconds. Okay. So I'm connecting on this box, and I'm going to tell master to start the master and to start the two nodes. So I'm starting it, and then I will explain how it goes, because it requires some time to start. So it's going to ping the node, and then it's going to start the stuff. So I'll go back to the presentation while it's starting. What I'm doing here is basically I've taken it a bit the hard way. I'm using a Fedora distribution on Raspberry 4. The Raspberry 4 is not yet supported by the Linux kernel, I mean the base kernel, so you have to use the Raspberry Pi specific fork of the Linux kernel. It needs to be cross-compiled, so you can. It's quite easy on the laptop. You have to install the ARM64 cross-compilation tool and build your kernel. You have to build it for a Raspberry 4, and you have also to add some stuff that Fedora is requiring, like to have the sync working for SULinux, and you have some parameters also to set for Kubernetes. This is you can find it in my under my URL there. There's not so much stuff there. So to build, you just tell that you want to build this config. That's it, building the configuration files, and then you make image modules, and then you will have the kernel and the modules and some other file you need. Then you need to prepare SD card. Basically. It's easy. I have Raspberry Pi SD card there where I have installed the stuff, and I can normally show what is inside. You will see. So it's a bit small, but it's readable, no? Okay. So basically, this is my card. This is the boot. This is a DOS or a FAT that is going to be read by the bootstrap of the Raspberry. The bootstrap of the Raspberry is done by the graphic card or the Broadcom card, which is going to read this, load the kernel in memory, and tell the kernel that it needs to run on ARM64 version, and then start it up, which is what has been done. And you have the root partition of the Raspberry. I have used very big card because I also want to run OpenShift on it, and you can do it with 32 without problems. And you probably could use smaller ones, but the smaller SD card doesn't worth it. So back to the presentation. So you have seen the starting is running in background. The next problem I have is like basically I have to set up the Wi-Fi. To do this, you have two ways. You can either copy the file at the right place in the Raspberry Pi. It's doable. It's easy. I'm not going to explain it because I've done it the other way, which is basically just connecting my Raspberry Pi to my router at home. And I make a nmap, find out that it's a Raspberry. I have previously copied to it the Raspberry is starting SSH and has my keys on it. So basically I just have to SSH to it as root and then install what is needed. So basically I'm going to get the configuration for the Raspberry 4. I'm going then to install some tools to do, and then I'm going to configure the Wi-Fi. Fedora 31 has some funny kernel feature, which is MAC address randomization. So there I have to edit the file and say never, because otherwise I have some problem to find my Raspberry. The description of what is running there, what is running on the infra, if you look, you will find a Raspberry Pi network here. It's Raspberry 3, I guess. You can guess the password easily from my Facebook friends and information. In my other demo, I'll let everyone connect to it to play with it, but we won't have time for that. So the explanation of how to set up this box is on my blog. You can have a look to it. I can show more stuff on it after the presentation, like open it and show you what you need inside, because basically it's going to run Kubernetes without an internet connection. So I need a real-time clock, I need a DHCP and DNS to have all those things running. So all this is explained in my blog. If you want to try it, just go there and have fun. The next problem I had is like, of course, I need to build ARM64 images. The cool thing is like ARM64 images, there's a lot that are available. I have tried it with CentOS 7 and the Alpine kernel. The Alpine kernel, the Alpine Linux is good because it's quite small. Basically, what I did is like, I used this Raspberry and installed Docker on it and Java, Maven. I'm doing Tomcat stuff, it's obvious. So basically, I have built these things. A small note, I was doing the same on my laptop to make sure that I understand everything. Thank you. And then basically, you need to take care of multi-platform if you want to use the same image name. Otherwise, the first time you start the stuff on the Raspberry, it's going to tell like it's a wrong image. So you must make sure you have the right, use the manifest tool in order that Docker is able to put it in the Docker up the right information. So basically, you have the information that this image is for ARM, this image is for S390, this image is for ARM64, and so on. So basically, it is this. I won't jump into detail. You use the Docker build. You tell him which arch you are, and then the important thing is in this file that you have done on the Tomcat demo, the YAML file. On the master, you have to, so this is basically what is running in background. You have basically, I've run this demo several times, so I have to clean it. I have to play a little with IP table. I have to remove the swap because otherwise kubeadmin does not want to start. And then I need a Kubernetes network. I have choose a wave to do that. You have a lot of others, but this is the first one I tried and it worked, so I stay on this one. I'm open to suggestion. I can do tries. It's very easy. Like it's my own Kubernetes, so I can do what I want. We can try. I can try other stuff. And so basically, then I'm going to do whatever you would do if you use Kubernetes. I will basically copy the configuration to my local configuration, so I can run on this guy, but I can have done that on my laptop. I can run the command on the Kubernetes things. So basically, to install the network is going to something like kubectl apply -f and the name of the file. I have a local copy of the plugin in my repository, but it's just wget from the original one. On each node, well, you have to do a kind of same thing. You're just going to join your Kubernetes cluster. Basically, you have a command to do that. You just kubeadmin cluster token create. It's going to give you the token, and if you say print join command, it will just basically tell you which command you have to run on the node to make this node join your Kubernetes cluster. And once everything is done, you can make a kubectl get node to see your nodes that are running. We are going to try it. So here, kubectl get nodes. And you see, I have the nodes running. Green is obviously the one which is displaying in green. The blue is the one displaying in the blue is the one displaying in blue, and master is this one which is hidden there with have no color. So it had been started while we were explaining the stuff. So I have my Kubernetes running. Let's try to have some fun there. So the next fun I want to do is basically move from a Tomcat cluster to a Kubernetes cluster of Tomcats. So basically, I have one problem. I'm jumping quite fast. I hope everyone knows what is web and HTTP. So basically, I have one problem. The protocol does not have the HTTP 1.1 does not have a transaction as a persistent connection. So basically, you need a cookie to carry this information. And if you are in a cluster, basically, you're going to create a cookie and you're going to store the information of the user on the server, and you associate it with one cookie. In this case, it's the session ID. So basically, what I'm going to need is like basically, I need to replicate the session information between the two nodes here, because of course I can't be sure on which Tomcat the things is going to arrive. So this is the things. So how the Tomcat cluster is working? It uses multicast. We don't have multicast in Kubernetes for the moment. So basically, you have to wait. You have to this guy have to discover this guy. So you can use the Kubernetes API to do that. This is very easy. It's the internal thing. It's like this is like you make a get. Well, you need to be encrypted and all that stuff, but this is a decrypted version of it. The data is wrong because basically it was a try without the clock working. And you can see that it's going to tell some information like where it's running, especially what I want to know is the pod IP, which is the IP inside the Kubernetes network. So basically with this, I'm going to be able to find from this guy, where is this guy, at which IP it is. So I can exchange the session information. So when I will run my small application on my HTTPD, I will basically be able to arrive on the right Tomcat. and on one Tomcat, but I will have the right session information on both. So basically, I don't care on which one I'm arriving because I've been exchanging the session information. Kubeping is a bit tricky because you need some permissions. So in this case, it's not a big problem. But if you're running on a real cloud, you won't have those permissions. You will not ask your administrator so that he give it to you. So there's another way to discover the other node. It's just basically, we name it Kubeping. You can look for it. It has been invented by the Infinispan guys. So basically, here you just make a NS lookup. So basically, well, this is an OpenShift example. It works the same way. Well, the command is a bit different. So basically, you make an NS lookup on your namespace, and then you're going to find the Tomcat. This is the way this guy is going to discover this guy, and this guy is going to discover this guy. So in my demo, in the next page, I'm going to see. I have HTTPD running here. This HTTPD is going to be able to find the different load balancer. I need to start the demo, otherwise I will run out of time. I will run out of time now. Okay. So here, basically, I'm in my Kubernetes cloud, and I'm starting my pods, and you can see basically what it do. It create a namespace, put it set on its namespace, then it start the Tomcat pods and create a different service. It create one service which is a DNS service, so that the NS lookup will work on both of these. And then I have the two Tomcat which are starting, which at some point are going to be up, hopefully. So one is running, the other is not yet ready. Okay, at some point they're going to be ready. So what you do in Kubernetes is like, basically you're going to have one Kubernetes proxy on each of those running, is knowing the other node. So basically what we do is like you can connect on any of those members of the of your cloud with the right port to access to the service. So basically to create my to make my HTTPD, which is running here, distributing the load between the two Tomcat. I don't care. I'm going to tell him like any of those member of my cloud is able to do the routing. This is Kubernetes which does the routing for me. What I like to mention is like you need a Docker registry. The Docker registry is running on this box, and it's very easy. It's a simple command. You start a Docker registry, say Docker run on the port. You have to be a bit careful so that Kubernetes does not complain, because it's a demo, so it's unsecure. 1 minute. It's unsecure on purpose. You pull the image, and then the things have been running. So now my demo should be ready. So normally I could join my HTTPD there, and then this is the Tomcat running, and when I refresh a bunch of time, the counter should be increasing, and it should be moving from one node to the other, and that's it. So basically, I've proven that my Tomcat software is working, and then the session is shared between the two nodes which are running there, and shared between the two pods. It's the same if I would run 10 pods. If I scale up, as I have only 2 nodes, I will have, if I scale to 3, I will have 2 Tomcat running on this one maybe, or 2 Tomcat running on this one and 1 on the other. And I guess I'm out of time.
Yes.
If you have questions, you can come to me after.